We are going to talk about time now, and then we'll keep digging downwards in the abstraction layer. So phases are periods of time in which something interesting happens, and what you can and cannot do changes depending on which phase you are in. So the init phase is the first one that happens right when the master process is created. There is nothing else, no workers yet. And the master process needs to do its stuff. And then there's Kong related stuff. Like, you can see the whole list here. I have already mentioned quickly before that one of those things it does is creating the Lua virtual machine. It's worth also noticing that this particular phase is not available for plugins. I will be marking the phases that are available for plugins and those that aren't, and usually at the last line of these bullet points. I'm not going to go over every single bullet point, but I think these slides can serve as a good reference. I will talk about the highlighted ones only. So I mentioned before that the virtual machine is created by the master process and then gets copied. This setup is one of the most confusing, or was one of the most confusing things for me to understand when I was trying to develop my first plugins. Until I understood this, it was very difficult for me to, in particular, understand how global variables worked on a plugin. Sometimes they seemed to be working just fine, and suddenly they stopped working, and I didn't understand why. Okay, next phase after init is the init worker phase. This is executed once per worker. A reminder that workers get a copy of the master Lua virtual machine. This means that any global variable that was initialized on the init phase, they get a copy of. But if they try to make modifications, those modifications are local to the worker. And connections, new connections, don't necessarily reach the same worker every time they reach a node. So it's possible that those modifications are not there when the next connection arrives. It's somewhat difficult to explain. I can explain with another diagram at the end. Notice in blue at the bottom that the init worker phase is available on plugins. Now, when a request arrives to the Kong node, it goes down to a connection and it starts getting treated. Now we are not on the office level anymore. We are now on the person level. Each connection can be thought of as a person, and the phases on which we treat a request, which are several, can be thought of more or less as the hours of a day of a person. So when the request arrives to Kong, there are several pre-proxy phases, which are similar more or less to things that people do in the morning before work, like having coffee, getting a shower, and so on. First one is the certificate phase. I have already mentioned on the previous abstraction level, the keep alive connections. This is the phase that it's working with them. When there is a TLS connection, there is this TLS handshake, and then we get this special phase executed, but it does not get executed on every single connection, only when the TLS handshake is done. And since we have the keep alive it doesn't happen every single time. As a result, one special thing that this phase does that no other phase does is that the context, which is a variable that lives for the whole duration of the request, gets cleared after this phase gets done. This means that if you create a plugin that sets something on the context on the certificate phase, it is not going to survive until the next phase. So you have to take that into account. Probably don't touch the context on the certificate phase. The next phase is the rewrite phase. This one is kind of special. On a human, it would be similar to waking up and not knowing who you are yet. And I say this because on this phase, the router has not been executed. That means that you still don't know which service or route got matched by the request that just arrived. So there is very little things you can do. I tend to think about this phase as an early exit phase. For example, if you are sure that your Kong node will only answer to GET requests, you could implement a very simple plugin that on the rewrite phase rejects any non-GET request. This would be a bit more efficient than doing it later because the router won't execute, so it's going to be faster. But that's more or less it. I have not seen this particular phase being used by any of our open source plugins. It's true that I didn't look very, very deeply. Probably one of them uses it, but most of them don't. Access, on the other hand, is the most usual one. This is the one that I think is the coffee or the breakfast one that almost no one skips. It happens after the router has been executed, so you know which service or route is being matched. And it also has an access phase on plugins, so this is probably the most popular phase to implement on a plugin. And we'll talk about plugins a bit later on the next phase. On the next chapter. But you can see that there are a lot of things that happen on the access phase besides those two that I mentioned. Again, you will have the slides for later if you need. Pre-read is the same or the equivalent of access, but for TCP or UDP connections. The router is also executed, and you have a pre-read phase on plugins for those plugins that support TCP and UDP. Okay, so now we are ready to proxy, or we are going to proxy. That means sending the request to the upstream API on this case. That is kind of similar to commuting to work and then doing work outside your home, more or less. The content phase is implemented by a module built in C. And it's kind of hard-coded. It's kind of not available to Lua. So as a result, it's not available to plugins. In parallel with this phase, there is a pseudo phase of shorts called balancer. This balancer phase happens can happen several times per connection. Basically, what's happening inside this phase is that we try to connect to one upstream, and if it doesn't work, we try another one, and if it doesn't work, we try another one until we run out of upstreams or one of them sends a valid response. So that is why we call it pseudo phase. Since it happens inside the content phase, we cannot, for now, make it available for plugins. And when a failure happens, a series of not very important things happen. You have this as a reference if you need it. Now, response, how do we send the response is very interesting because it's different from how we treat the request. As you can see, both lines are highlighted here. And that's because we treat the response as a chocolate bar that we don't eat in one go. We split it into small pieces and we process it piece by piece. So the first piece is the one containing the headers. This means that as soon as the last byte from the headers, the response headers, arrive to Kong, it will start processing this phase, or this phase starts. And at the end of this phase, Kong will send the headers back to the consumer so he can have the headers faster. The consumer doesn't have to wait for the whole request to go through Kong. It has a header filter phase available on plugins. And now we get to the body, and the body is even crazier because you don't get a single phase for processing the response body. You get multiple. So you get the first chocolate block, and then since potentially responses can be huge, I'm talking about, imagine video responses or even images, or sometimes even JavaScript zip files. So one thing you don't want to do is having to allocate memory or disk space for the whole thing if you can avoid it. So you treat it chunk by chunk. As a result of this treatment, you only have to allocate the memory or space for each chunk individually. So that is why you do it, but it is kind of uncomfortable. If you want to make a transformation on a JSON response, this way of treating the body is kind of not very user-friendly. So recently, because of this and because of needs on the non-Lua plugins, which are a recent addition, we have now another pseudo phase called response. Response basically replaces header filter and body filter. It does not split the chocolate bar into small pieces. It eats the whole chocolate bar in one go. Headers and body filter, and body at the same time. This means that it has the inconvenience that I mentioned before. You have to have space to hold the whole thing up. And if you are serving videos, this can be huge. It has an extra thing to take into account, which is that when any of your plugins has a response phase, that activates buffered responses globally. This means that all your connections from all your Kong nodes, from all your workers in the node will wait until the chocolate bar is complete before sending them back to the customer. So don't use this willy-nilly. Be very aware of the constraints. Log phase is interesting because it happens after the response has been sent back to the consumer. It's free time in the sense that anytime you spend here is not going to affect the user experience of that particular connection. However, keep in mind that anytime you spend here is time that you don't spend serving other connections or on other timers. So it still affects the global efficiency of the system. And one particular wrinkle the log phase has is that co-sockets, which are what you use to to communicate with the outside world of Kong cannot be used on this phase. So you have to get around that limitation by using timers. But I mentioned before that timers, one timer per request is an anti-pattern. So things get tricky that way. The log phase would be similar to going to bed at night and dreaming. So you don't do any more work. Last pseudo phase in this case is the handle error phase. Anytime something bad, unexpected happens, like what you see there, an unmatched route or the upstream not responding, basically this gets run, and then the header filter, body filter, and log phases happen, but with a default not user configurable response. And it's not available for plugins, partially because a plugin can throw an error. So this is on top of that. So if you wanted to see this on a schema altogether, it looks like this. I decided not to do this presentation on top of this because it's kind of difficult to talk about a schema like this, but feel free to use this as a reference. Now, last thing was plugins. And I wanted to mention that plugins, which are pieces of code inside Kong that change stuff, are similar to hands. If connections are people, plugins are their ways of changing things. So the first thing plugins can do is talk with an external system. All our logging plugins and the tracing ones like Zipkin and Prometheus are basically doing this on the log phase. So the user isn't impacted. The next thing plugins can do is talk with an external API. Modify the request when they are talking to the external API. We don't do this often. These are the two plugins I found. And interestingly, well, not surprisingly, I would say, the access phase is what gets used here. The other thing we can do is modify the other arrow that exits Kong. Again, very few examples of this as a pure mechanic. Response transformers and response transformer and course are the two plugins I found that are purely doing this. It's surprising that course in particular does setting of headers on the access phase. That's something that is a bit surprising. Sometimes you can set the headers of the response before you have even sent the request to the upstream server. And one special case of sending a special response is actually the most useful or most used structure of plugins, which is shortcutting. All of these plugins, well, the authorization plugins, of course, reject requests if they don't, if the credentials are incorrect. But others like bot detection or IP restriction also help alleviating the traffic on the upstream and keeping our customers happier without traffic that they don't want. Again, the most popular phase on this case is the access phase. So in conclusion, Kong is full of very tiny people who do most of their work either on breakfast or dreaming at night, and they like to eat their chocolate in small chunks.